Chapter 8, Gravitation. In last lecture, we discussed gravitational potential. Recall its definition. It is negative of work done by gravitational force in bringing body of unit mass from infinite distance to a point in the gravitational field is called gravitational potential at that point. Remember, you have to bring unit mass from infinite distance to given point in definition of gravitational potential. Today we will see one similar topic with a small change, that is gravitational potential energy. So now, how to define this gravitational potential energy? See, first of all, I will write its definition. The negative of work done by gravitational force in bringing body of mass m. Yes, it is changed. Okay, the negative of work done by gravitational force in bringing body of mass m from infinite distance to given point in gravitational field is called gravitational potential energy of that body. Okay, to see what is that minor change. That minor change is only this: body of mass m. Yes, it is only minor change. Okay, in definition. So is it clear about definition? Okay, what is definition? Yes, it is negative of work done. By gravitational force in bringing body of mass m from infinite distance to given point in gravitational field is called gravitational potential energy of that body. Actually, it is potential energy. Of system of Earth plus body. If we are taking example of Earth, okay. If we are taking example of Earth, okay, for example, it is Earth. For example, it is Earth. It is its radius. Suppose we bring unit mass m from infinite distance to given point. Having position vector r and distance r at this point P. Okay, so again, see, understand definition. The negative of work done by gravitational force in bringing body of mass m from infinite distance to given point in gravitational field is called gravitational potential energy of that body. Okay, but actually it is potential energy of the whole system, Earth and body. But as velocity or whatever change in velocity, or you can say acceleration, is experienced experienced by only body. By only body. It is considered potential energy. It is considered potential energy of body. Okay, for example, if I have this chalk, yes, it is in gravitational field of Earth. So if I find some gravitational potential energy of this chalk, then it is the gravitational potential energy of whole system, Earth plus chalk, but due to that, the whatever effect it is experienced by this chalk only. Okay, if I drop this chalk will move in downward direction. Means there is change in velocity of this chalk. There is acceleration produced in this chalk, but there is no change in velocity of Earth. So that's why you have to remember this statement. Okay, actually potential energy is of whole system. It is of whole system, but as that all effect is experienced by object body itself, that's why it is considered as potential energy of body. Okay, now how to obtain equation of gravitational potential energy? Hello, what is difference? Difference is you have to put only mass m. So remember last theory. First of all, you have to find force. Equation of force, F is equal to G me 1 upon r square. Yes, you have to replace that 1 by m. So in each and every equation, you will get m, and at last you will get this equation. See here, point P is at distance r, which is greater than radius. Yes or no? Point P is at distance r, which is greater than r. So therefore, potential energy at point P. What is potential energy? U is equal to minus Gme upon r into m. Yes, you have to just multiply m. Okay, U is equal to, it is minus Gme upon r into m. Yes, we do not have to prove the whole theory again. Just you have to write direct equation, or with the help of definition also we can say gravitational potential is for unit mass. Potential energy is for body of mass m. So simply you have to multiply mass. Yes, we know that minus Gme upon r, it is for gravitational potential. So yes, from this we can obtain one relation between gravitational potential and gravitational potential energy. So therefore, U is equal to, it is phi m, where phi is equal to minus Gme upon r, that we have proved. Okay, so what is U? U is gravitational potential energy. Phi is gravitational potential, and m is mass of body at that point. Okay, so yes, you have to remember these equations. If body of mass m is on surface of Earth, okay, then U is equal to, it is, you have to just replace r by r. Okay, so U is equal to, it is minus Gm upon r. So you have to remember this equation also. If body of mass m is on surface of Earth, r is equal to r, U is equal to minus Gm upon r. Clear about this? Okay, so it is equation of potential energy. Yes, it is equation of potential energy. Okay, now see, absolute value means individual value of potential energy Okay, absolute value of potential energy is not important. Is not important. Important is change in potential energy. Important is change in potential energy, and therefore we have to select. Therefore, we have to select point of reference. Point of reference where potential energy is zero. Potential energy is zero. Remember chapter number 6, work energy power. Yes, we have obtained one equation of gravitational potential energy. U is equal to mgh. U is equal to mgh, but that h is height from surface of earth, because at surface of earth we are taking or we are assuming potential energy as zero. So yes, U is equal to mgh. U is equal to mgh. It is not absolute value, it is relative value with respect to surface of earth, because at surface of earth potential energy is zero. Clear? So here, at which point we have to consider potential energy zero? At infinite distance. Because at infinite distance, force is zero, so potential energy is also zero. Yes? Okay. We have to select point of reference where potential energy is zero, and at infinite distance, as R is equal to infinite, we can say potential energy is zero. We can say potential energy is zero. Okay, so now whatever potential energy we calculate, it is with respect to infinite. Clear? Okay, we have to find potential energy with respect to this infinite. Clear about this? So yes, it is simple. Again, in definition, only this change. Okay, the negative of work done by gravitational force in bringing body of mass m from infinite distance to given point in gravitational field is called gravitational potential energy of that body. But actually, it is the gravitational potential of energy of Earth plus that body. But all the effect as it is experienced by body itself, it is called potential energy of body. Point P at distance r, potential energy at point P is equal to minus gmem upon r. So you can write U is equal to phi m. Yes, you have to remember these relations. Okay. If body is of mass m is on surface of Earth, r is equal to index I. So U is equal to minus gmem upon I. This equation is important. Okay, this equation is important. Okay. And yes, last one is clear about this. So yes, it is gravitational potential energy. Okay, this is it. Okay, now we will see one question which is based on gravitational potential and gravitational potential energy. See what is question, and yes, it is one important question. Okay, if you are given one square of side L on corner of each corner of square object having mass m are placed. Okay, so yes, figure is clear. Okay, K at each corner, mass m, they are placed. Okay, at each corner of square. At each corner of square mass and they are placed. Your first question is find potential energy. Find potential energy of system. And your second question is find potential. Only potential, okay? Gravitational potential. I will write in detail. Find gravitational potential at center. Find gravitational potential at center. So again, yes, it is one most important question. You are given one square, at each and every corner mass m placed, side of square is L. Find potential energy of system. Potential energy means gravitational potential energy. Okay, gravitational potential energy of system. And second, find gravitational potential at center. Okay. First of all, we will find gravitational potential at center or whatever. First of all, we will find first question. Okay. The potential energy of system. Gravitational potential energy of system. Yes, how to find gravitational potential energy? Remember, whenever you are asked to find question on gravitational potential energy for system of masses, first step is to identify numbers of pair between masses. What is the meaning of numbers of pair between masses? See, if you are given two masses m1 and m2, okay, then yes, there is only one pair. If you are given two masses m1, m2 and m3, three masses, then numbers of pair, yes, first pair is between 1 and 2, second pair is between 1 and 3, and third pair is between 2 and 3. So there are three pairs possible. Hello? Yes or no? Yes. So if you are given two objects, only one pair is possible. If you are given three objects, three pair possible. Now if you are given, here in this case, one pair. Here in this case, total three pair possible. Okay. Whenever you are given four particles, then first of all you have to identify numbers of pair. Numbers of pair. So for that, first of all, we will name this square, that is ABC. Okay, as it is square, it is L, here it is also L, and here it is L. So yes, identify numbers of pair. See, first pair, M, it is first pair, first, second, third, and fourth. Yes or no? Then it is 5, and here it is 6. 6 pair. Yes, 6 pair. See, again, first, second, third, fourth, fifth, and sixth. Out of these 6 pair, 4 pairs are identical. How? See, first pair is between AB, mass M, distance between them L. BC, mass M, distance between them L. CD, mass M, distance between them L. DA, mass M, distance between them L. So yes, first I will write one equation for them. Okay, 4 pairs like AB. 4 pairs like AB. So therefore, potential energy of only these 4 pairs. Potential energy of only these 4 pairs. I can write like this. Okay, U1 is equal to 4 in bracket minus G and M upon N. Now this equation is from, yes, it is from here. Remember, G, M, E, M upon R. minus G MEM upon R, minus G MEM upon R. Yes, for potential energy you have to write this equation. Okay, if you are given two objects having masses M1 and M2, distance between them is R, then potential energy U is equal to is minus G M1 M2 upon R, minus G M1 M2 upon R. So similarly, MM, distance between them is L. Okay, 1, 2, 3 and 4. So I can write directly like this. Yes or no? Hello? So is equal to is minus 4 G M square upon L. Now, out of 6, 4 pairs like AB, remaining 2 pairs, it is AC and BD. But you know that AC and BD, they both are diagonal. Yes, they both are diagonal. So therefore, 2 pairs like AC. So I can write therefore U2 is equal to, it is 2. Yes. Minus, yes. G, yes. What is mass on A? M. Mass on C is M. So it is mm. But what is distance between AC and BD? Hello, it is simple, okay? It is square, and in case of square, this diagonal, how to find this diagonal? I will find here. Okay, from figure. How to write from figure? From figure, AC is equal to AB square plus BC square. So I can write like this. AC is equal to under root H square plus L square. See, AC is equal to under root L square plus L square. So AC is equal to, it is root 12. So here it is root 12. What is distance between AC or AD? It is root 12. Hello? Clear? Okay. So therefore U2 is equal to 2 upon root 2. I can write this 2 as 2 is equal to root 2 into root 2. So 1 root 2 cancels out. So 1 root 2 remains. So it is minus root 2 G M square upon L. Any doubt? Okay. So 4 pairs like AB. 2 pairs like AC, total 6 pairs. So therefore, total gravitational potential energy of system U is equal to, it is U1 plus U2. Chalo, what is U1? It is minus 4 Gm square upon L. What is U2? Minus root 2 Gm square upon L. So yes, it is equal to minus Gm square upon L 4 plus 2. So minus Gm square upon L 4 plus. Clear about this? Okay. So yes, it is first question. Okay, how to find potential energy? Again, to find question of potential energy for system of masses, you have to first of all identify numbers of pairs. Yes, numbers of pairs. And for that each and every pair you have to write equation. Here there are some identical pairs, so I can write directly. Clear? Any doubt? Okay. Now second question. Okay, find gravitational potential at center. Find gravitational potential at center. Gravitational potential at center. Gravitational potential at center. See, for potential, you have to ask one simple question. Okay, potential is produced due to mass. Potential is produced due to mass. Potential is produced due to mass. There are 4 masses. There are 4 masses. One A, B, C, and P. And you have to find potential at center, at point O. At point O. Okay, gravitational potential at center. That is O. Okay, so again one simple question. Gravitational potential is produced due to mass. Yes, there are 4 masses. M, 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 M. 4 masses are identical. At center. So at center due to A. So between A and O, distance is R. At center due to B, as it is square, this distance is also R. Due to C, it is R. Due to D, it is R. Yes or no? And so how to write? So see, gravitational potential at center, that is O, phi is equal to minus, 4 times minus Gm upon R. Why directly 4 times minus Gm upon R? Because there are 4 masses. All masses are equal. Distance of each and every mass from center is also equal. So magnitude of gravitational potential is same. So you can directly multiply for half. What is R? R means what? R means center to corner distance. R means center to corner distance. See, we know this distance AC. What is distance AC? Root 2L. So here R is equal to AO is equal to AC by 2. What is AC? It is root 2L divided by 2. Okay? So R is equal to, it is root 2 divided by 2. So it is L upon, clear? So put value in equation. So phi is equal to, it is 4 minus Gm upon L upon root 2. So phi is equal to minus 4 root 2 Gm upon L. It is equation of gravitational potential. It is equation of gravitational potential. Clear? So yes, it is one important question to find gravitational potential energy of system, and second, find gravitational potential at center. Okay? Yes, it is one easy question. This is it for today. Is it clear? Okay, it is clear. Tada.